Welcome to Faraday Junior YouTube channel. In this video, we are going to look at post-optimality analysis. When we say post, it means after. So optimality analysis, it means this is simply an analysis we do to gain in-depth information of a linear program after we've gotten our optimal solution. And so the analysis of the optimal solution in order to gain additional information, this is known as the post-optimality analysis. Yes. So this optimality analysis, post-optimality analysis, can be done in two ways. First, we have the duality analysis and then the sensitivity analysis. We have the duality analysis. So, I said, we all know that for a linear programming problem, for an LP problem, it has two forms. It has the original form, that's the primal, and then it has the second form, that's the dual form. So for the duality analysis, in order to do that, first you have to convert the linear programming model into the second form, that's the dual form, before you do your analysis to obtain useful information regarding the value of resources that forms the constraints of the model. Yes, so this is the duality analysis. And then we have the second one, that's the sensitivity analysis. So the sensitivity analysis, we use the various numerical coefficients in the model constraints and the objective function to do this analysis. This analysis, it helps us to see the sensitivity of changes in them to the optimal solution. So when you have an LP problem, you use the coefficient of the constraints, to see how, whenever there is a changes in the constraints, how it affects the objective function. This is the sensitivity analysis. It deals with changes. Yes, that's it. So let's look at the duality. Let's first look at the duality. So why do we do the duality analysis? This helps us provide economic interpretation. So economic interpretations of the resource parameters of an LP problem. And then sometimes too, occasionally doing the analysis of the on the dual form might be easier, or will be easier as compared to the primal. That's how you do the duality analysis. So let's take an example, and then from there we'll get to know more about what I'm saying. So let's take this example. So let's consider the following problem. A firm manufactures two products, that's product 1 and 2. The production of product 1 and 2 is subject to the following resources requirements and availabilities for labor, material, and then storage space. So this is it, and we already have the linear program formed for us. This is the LP. It's formed for us. So what you have to do is to solve this using the simplest method. So first of all, what do we have to do? We have to convert this to the simplest standard form. So let's do that. So converting this LP to the simplest standard form, you have x1 plus 2x2 plus s1, which is equal to 10. We have 6s1 plus 6x2 plus s2 is equal to 36. Then we have 8x1 plus 4x2 plus s3 is equal to 40. So our objective function will now be 4x1 plus 5x2 plus 0s1 plus 0s2 plus 0s3. So let's quickly draw our simplest table. So we have our CJ here, and in the CB here we have our basis we have BI, we have X1, X2, S1, S2, S3. Okay, so let's look at the coefficients of the variables in the objective function. We have 4, 5, 0, 0, 0. Okay, then okay, from the first constraint, we write the coefficients here. We have 1, 2, S1 is 1. You don't have S2 and S3 here, so it will be 0, 0, 0. And then the second one, we have the coefficient of X1 to be 6, and that of S2 to be 6. And then it is 1 here and 0 for S1 and 0 here. Let's do the same for the third one. We have 8 here, 4 here, 0, 0, 1. So here will be our ZJ. Okay, so let's calculate for, okay, let's first look for our BI. BI is the values at the right hand side of the constraint. So 10, 36, 40. And the basis, we have S1, S2, S3. You can see it is forming a 3 by 3 identity matrix here. So that is it. Alright, so let's go ahead and calculate for our ZJ values. So ZJ is simply multiplying the values here by the coefficient. So the coefficient of S1, we have 0, 0, 0. Yes. So the coefficient of S1 is 0. So 10 times 0 plus 36 times 0. Because we have all the CB values to be 0, which means that we are going to have 0 for all our variables. So we calculate for CJ minus ZJ. So these are CJ values. 4 minus 0 will give us 4. 5 minus 0 will give us 5. 0 minus 0 is 0, 0, 0. So we look for the largest non-negative number. That's 5. So this will be our entering variable. And that's our pivot column. So we go ahead and look for the pivot number. How you look for the pivot number? You take your BI and divide it by the corresponding value in the pivot column. So let's do that. Our first BI is 10. What's the corresponding value in the pivot column? That's 2. So 10 on 2, that'll give us 5. And then we have the second BI to be 36. And what's the corresponding value in the pivot column? That's 6. So that'll give us 6. And then we have 40, and the corresponding value in the pivot column is 4. So 40 on 4, that'll give us 10. So the minimum value here is 5. It says 510. The minimum value here is 5. And the corresponding value in the pivot column is 2. This 2 that we divided. So 2 is our pivot number. And then this will be our pivot row. That's out. So S1 will move from the basis and replace it by X2. So let's draw our second tableau. Alright, so CJ, CB, we have our basis here, BI, X1, X2, S1, S2, S3. Then we have CJ here. Alright, so how do you get our values for the second tableau? what you have to do is for the pivot row, you divide all the numbers by the pivot number. So this is the pivot row. This row is the pivot row. So you divide all the values by the pivot number. So 10 divided by 2 give us 5. 1 divided by 2 give us 1 on 2. 2 divided by 2 give us 1. 1 divided by 2 give us 1 on 2. 0 divided by 2 is 0. This one 2 is 0. Then we come to the second row. That one, you use this formula, the old value minus the corresponding value here in the pivot column, that's 6, times the new value here. So new value. Okay, so the old row value here is 36 minus 6 times, what's the new value here? 5. 6, 5, 30. So we have 36 minus 30. That's going to give us 6. So we have 6 here. And then the next one, we have 6 here. That's the old value. Minus 6 times, what's the new value here? 1 on 2. So 1 on 2. So 6 minus 3 will give us 3. So this will be 3. I know you know how to do this, so I'll just write down my values for the rest. So 0 minus 3 1 0. So you do same for the third column. You do it with respect to the pivot row. So let's do for the first two. We have 40 here. So that's the old value. 40 minus, what's the corresponding value for that row in the pivot column? That is this 4. So 4 times, what's the new value here? 5. So 40 minus 20, this will give us 20. So our new value here is 20. Let's do same. Our old value in that table is 8 minus the corresponding is 4, and the new value here is what? 1 on 2. You won't use the 3, you use the pivot row from the previous table. That's 1 on 2 times 1 on 2. So 8 minus 2, that will give us 6. So our new value here is 6. So you do same for the remaining ones. 0 minus 2 0 1. All right, so let's calculate for our DJ values. Oh, sorry, our basis. So as I said earlier, the x2 from the previous table, you realize I said x2 will enter the basis and then s1 will go out. So we have x2 here, s2, and then s3. Yes. So our ZJ values. What is the coefficient of x2? Coefficient of x2 is 5. And then we have 0 here and 0 here. Alright, so our ZJ values. 5 times 5 is 25. Plus 6 times 0, which is 5 times 5, plus this 6 times the 0, plus this 20 times the 0. 20. So all this will go to 0, and you have 5 times 5, which is 25. So we have 25 here. And then you do same for here. So 5 times 1 on 2, 3 times this 0, 6 times this 0, then you add them. So we are going to get 5 on 2 for here. We're going to get 5. We're going to get 5 on 2, 0, and then 0. Alright, so we go ahead and calculate for our CJ minus DJ values. So CJ minus DJ values. So these are CJ values. 4 minus, so 4 minus 5 on 2, that will give us, sorry, see, 3 on 2. And then 5 minus 5 will give us 0. And then 0 minus 5 on 2 give us minus 5 on 2. And then 0 minus 0 is 0. 0 minus 0 is 0. So we look for the largest non-negative number here in the CJ minus J. So obviously this is the only positive number, and that will be the largest non-negative number. So here, so this is our pivot column. So that's the entering on basic variable. So let's look for the pivot number or the pivot row. As I said earlier, you take your BI value and then divide it by the corresponding value in the pivot column. So our first BI is 5. So 5 divided by what's the corresponding value in the pivot column? 1 and 2. This will give us 10. Then you take 6, that's the second BI value. 6 divided by the corresponding value here is 3. That will give us 2. And then 20. And the corresponding value in the pivot column is 6. So 20 on 6, that will give us 3.33. So what is the minimum value among these three numbers? You have 10, 2, and 3.33. That's 2. And the corresponding value is 3. So 3 is our pivot number, which means that S2 will go out. That's our pivot row. Pivot row. So let's go ahead and then draw our third tableau. Alright, let me bring my table. So CJ, CB, our basis, BI, X1, S2, S1, S2, and then S3. Then we have our CJ here, CJ minus CJ. Alright, so let's go ahead and then look for our values for the third tableau. So, as I said earlier, we all know that S2 will go out and then X1 will come in. So let's just write our basis first. S2 will go out and then S1 will come in. And our BI values, okay, let's calculate for, sorry, the CB value, the coefficient of the basis. We have 5 here, 4, and then 0. Okay, so let's calculate for our new values. So what's the pivot row? The pivot row was the second row. That's the S1 row. So you divide all the values in the pivot row by the pivot number. So you have 6 here, you divide by 3 to get your new value here. So 6 divided by 3 is 2. 3 on 3 is 1. 0 on 3 is 0. Minus 2 on 3. Minus 3. Minus 3 on 3 will give you minus 1. And then 1 on 3 will give you 1 on 3. And then 0 on 3 will give us 0. Now we go ahead and calculate for the values of the remaining rows. Like I said earlier, it's old value minus the corresponding value in the pivot column. So this one is 1 on 2. For this row is 1 on 2 times the new value here. New value. Alright, so let's do for the first BI 5. So the old value is 5 minus 1 on 2. And what's the new value here? We have the new value here to be 2. So 2. 5 minus 1, that will give us 4. So our value here should be 4. And then the next one, 1 on 2, that's the old value. 1 on 2 minus 1 on 2 times, what's the new value here? 1. So 1 on 2 minus 1 on 2 will give us 0. What's it? Yeah, 1 minus 1 on 2 times the new value here is 0. So 1 minus 0, that's 1. You have 1 here. So you do same for the remaining ones. I'll just write down the values. So here too you do same. Our BI value is 20 here. So the old value is 20 minus, what's the corresponding value in the pivot column? This is our pivot column, right? So the corresponding value is 6. So minus 6 times the new value. So what is the new value here? For the pivot row 2. So 20 minus 12, that will give us 8. So our value should be 8. Same thing for the next one. We have 6 here. 6 minus 6 times, what's the new value here? 1. That will give us 0. 6 minus 6, 0. So 0. Same for here. When you do it, you know the formula. So we just substitute your values, and then we are good to go. Alright, so our CJ values. Our CJ values is 5. We multiply the CB values by the BI values and then add all. So 5 times 4 plus 2 times 4 plus 8 times 0. 5 times 4 plus 4 into bracket 2 plus 0 into bracket 8. This will give us 20 plus 8 plus 0. That's 28. So we have our delay here to be 28. So you keep on changing these values. For every column, you replace these values. The values in the bracket. So here we are going to replace it by 0 because that's on the 5 row. 1, here will be 1, and then here will be 0. So 5 times 4 plus 4 times 5 times 0 plus 4 times 1 plus 0 times 0, that should give us 4. We do same for here. We are going to get 5, 1, 1 on 2, and then 0. So let's apply for our CJ minus DJ values. So CJ here is 4, DJ is 4, 4 minus 4, 0, 5 minus 5, 0, 0 minus 1, minus 1, 0 minus 1 on 2, minus 1 on 2, 0 minus 0 is 0. You can see that in our CJ minus DJ values, you will see that we don't have any positive number. They are all zeros and negative numbers. So therefore, we can terminate our simplest iteration here. So our optimal solution is x1 is equal to 2, s2 is equal to 4, and then s3 is equal to 8. So this is our optimal solution. Now let's do the post optimality analysis here, and then let's see how we can have additional information from the optimal solution we have now. So you can see that the CJ values under S1 and S2. You can see we have S1 to be minus 1 and then S2 to be minus 1 on 2. This is the same as minus 0.5. Which means that when these values enter the basis, there's going to be a decrease in the profit by $1 and then 0.5 respectively. Since you can also see that we don't have S1 and S2 in the basis, this means that we have fully used the labor and then the material resources. If you will check from our question, the S1 was the S2, was introduced. S1 was introduced for the labor constraints, and then S2 was introduced for the material constraint. So at the end of our simplest iteration, you realize that the S1 and S2 are not, that's the surplus, they are not in our basis. That means that we fully used the labor and then the material resources. We don't have any surplus left. And then for S3, you see that S3 is in our basis. S3 is here. That's the slack variable for storage space. And then it has a value of 8, which means that we have a surplus of, or we still have a storage space of 8 meters squares left unused. That's the interpretation to this. And also, you could see that if S1 enters the basis, it means that there's going to be a reduction of labor by 1 unit. The same way, if S2 enters the basis, there's going to be a reduction of labor by 1 unit. So if the entry of S1 is going to result in a reduction of labor by 1 unit, then it means that when we increase labor by 1 unit, there's going to be an increase in profit by 1 USD. And then when we increase the material by 1 unit, there's going to be a profit change by 0.5. So these values, this $1, and then the 0.5, these are called our marginal values. These values here, these are called our marginal values. They are also known as the shadow prices. That's the maximum price one is willing to pay to obtain more of the resources in order to maximize the profit. So these are the values when we pay, or any change in them. Or when you increase them, it means that there is going to be an increase in your profit. So as I said earlier, this is the marginal value. So the marginal value for S1 is -1, and that of S2 is 0.5, and then that of S3 is 0. That's the prices one is willing to pay to maximize profit. Yes, this is for labor, material, and then storage space. So you could see that the marginal value for S3 or for storage space is 0. So this implies that there is no value on marginal basis for S3. This is because S3 is in the basis with a value of 8, which implies that we still have 8 meters squared space left unused. So therefore storage is not a binding constraint. We still have it in excess, so there is no value for it on marginal basis. So that's it for the post optimality analysis. I know at the end of